Hello, I'm Carl Nelson from the University of Nebraska-Lincoln. I will present design of a portable Venomanometer system for episcleral venous pressure measurement, which is work with collaborators at the University of Nebraska at Omaha and the University of Nebraska Medical Center. And the problem that we're addressing is the difficulty measuring whether TBI, traumatic brain injury, has occurred. Usually the biomarker that is used for this is intracranial pressure, but that is difficult and invasive to measure. And so we turn to an alternative biomarker, which is episcleral venous pressure, defined as the pressure applied to the episcleral vein in the eye necessary to half blanch it. So you can see in the panel of 4 pictures that you progressively apply more and more pressure to the vein until it appears half blanched. Of course, that term half blanched is rather subjective, so there is some variability in what EVP really means. So we rely on an existing device. An episcleral venomanometer has an elastic bulb that's placed against the episcleral vein, and inside this device there's a piston which is used to increase pressure in the bulb through a dial. And this device is typically used in a clinical setting with a slit lamp or an operating microscope. And what we'd really like to have is a portable device that's more field ready and field adaptable. So not in the very well controlled clinical setting, but more for field environments. So our solution to this is to take the existing venomanometer device and add a camera to it. The camera provides 4 functionalities: taking images, doing onboard image processing, logging data to the phone, and then transferring data off of the phone through wireless communication. We also have added components including lenses and lighting to produce the necessary optical conditions for good images, a small fine adjustment mechanism that's taken from a microscope to precisely position the bulb of the venomanometer against the episcleral vein, and a potentiometer that logs the position of the dial on the venomanometer and transmits that back to be overlaid on the image of the eye. There's a processor that participates in that data transfer and taking the potentiometer measurement and kind of merging all that data together. So we put all of this assembly on a portable stand, and that stand allows us to position the venomanometer assembly against a subject, either in the prone position or in a seated position as need may be. And there's a custom app that allows us to adjust focus and zoom and take still or video images, save files, and so forth. The results of testing this are rather interesting. We had 3 rabbits and were tested in both eyes by 2 different clinicians on 3 separate test days. And the images that you see here show that we are able to take good quality images and actually take the EVP reading. What we were not able to conclusively do is show that there is no statistical difference between using the venomanometer with traditional methods and using the venomanometer in this new system, which is what we would like to continue to do, is increase or improve the accuracy and repeatability of measurements in order to ascertain that similarity of performance and also harden this device for improved usability in austere environments. Thanks for listening.